Today, there's no questions, we're going to talk about properties of numbers. You don't have to write all this down. Just watch and listen. It's just review again. This is the same few slides I did in Algebra 2 today as you guys had last year in Algebra 2. So just a quick review of some properties of numbers and some vocabulary that maybe will spark your memory when we talk about it. So the first one is the additive identity property, and that says the sum, that's addition, right? The sum of a number and zero is called the additive identity, is the original number. You guys all know that. Anything plus zero is whatever you started with, right? So remember that zero is called the additive identity. For multiplication, the multiplicative identity is the number 1. You guys all know anything times 1 is itself. Product, remember, means multiplication. So remember that the number 1 is called the multiplicative identity. Inverses. Additive inverse property, the sum of a number and its opposite, or additive inverse, is 0. So if you're thinking of additive inverses, think of opposites. So any number plus its opposite will be 0, which is called the additive identity. All right? When we think of multiplicative inverse, we think of reciprocal. All right? What number do I got to multiply by to get the multiplicative identity? 1. So the example we used here was 8 or n. Remember, you can write 8 as a fraction as 8 over 1, so you just flip it. So think of reciprocal if you're asked to find the multiplicative inverse. Review stuff, right? You guys remembering this a little bit, hopefully? Closure property, okay? The sum or product, addition or multiplication of any two real numbers is a real number. So closure just means if I have types of numbers I'm doing operations with, add, subtract, multiply, divide, and I always get that same type of number, then that operation is closed for that set of numbers. In real numbers, we always get a real number when we add, subtract, multiply, or divide. Okay, so those, we're just doing additions, multiplication right here. But remember, this symbol means is an element of, and capital R means the real numbers. So to give you an example where there might not be closure, let's talk about the integers. Remember, that's the positives, whole numbers, 0, and the negative whole numbers, right? Remember that we talked about yesterday. If I think about the integers 2 and 4, and I want to divide, what's 4 divided by 2? 2, that's still an integer, right? But what's 2 divided by 4? 0.5 or 1/2, right? Is that an integer? No, so we can't say that the division of integers is a closed set or a closed operation because we get a different type of number. So hopefully that example helps you understand what closure is. All right, the commutative property says we can add or multiply real numbers in any order without changing the result. So if you look at a problem, the left side of it equals the right side of it, and you see that the order has been changed, you have been using the commutative property. It works for addition and multiplication, not subtraction or division. Associative property has to do with the grouping, what's in the parentheses. So if you look at the left side of this and the right side, you see the order's the same, 5, 3, and 7, right? Or A, B, and C. Well, on the left side, the 5 and the 3 are grouped, okay? But on the right side, the 3 and the 7 are grouped. So they changed what was grouped, but you still get the same answer. Watch. 5 plus 3 is 8, and then 8 plus 7 is 15. Over here, we're supposed to do 3 plus 7 first. That's 10. What's 5 plus 10? 15, right? So we get the same answer even though we changed the grouping. That's the associative property. That works again for addition and multiplication. not subtraction or division. Again, you guys have heard these before. It's just a little review, quick review for you. Distributive property is when you have a number out in front of parentheses and there's no symbol. That means 5 times that parenthesis, or 5 times the quantity, 2 plus 8. I could go 5 times 2, get that answer, and 5 times 8, and then add. So we could do 2 plus 8, get 10 times 5 is 50, or 5 times 2 is 10, 5 times 8 is 40, and add them and still get 50. You guys are really good at recognizing that. You know where that's distributed right when you see it. And remember, we could put numbers and letters too, numbers and variables. So just looking at the left side and the right side, what's different? What was changed? The order was changed, so what property was used? Commutative, right? Of multiplication. Looking at the left side of this one and the right side, I got too far against all. What was changed? The parentheses, what was in the parentheses, right? It's group. The order's the same, 3, 2, radical 8. So it's not commutative, but here 2 and radical 8 are grouped. Over here 3 and 2 are grouped. They're going to be equal to each other. They're going to be 6 radical 8. That's associative property. What they do here? Just change the order again, right? Commutative of multiplication. Again, remember, this works for addition as well. Again, they changed the grouping. The order was the same, 9, 12, 5, 9, 12, 5, but here 12 and 5 were grouped, over here 9 and 12, so they used associative. So you'll have a few problems where you'll see stuff like that and have to tell what properties they use. Okay? Another review. Please excuse my dear Aunt Sally. Right? PEMDAS, some of you call it PEMDAS, right? Remember that the P stands for parentheses. Do what's in parentheses first in the problem if you're going to try to evaluate it, find the answer. Then the E or EX stands for exponent. So if there's any exponents in the problem, you do those next. My dear goes with multiplication division. They have the same importance. So sometimes we might divide before we multiply, depending on when it shows up. You just read it like you're reading a book, left to right. Whatever shows up first, you do first. And then Aunt Sally stands for addition and subtraction. Same thing, they are both the same importance. So whatever you see first going left to right, you do. You guys know how to do that, right? So I would like you to do that problem right there without using a calculator and following the order of operations. Yes,
I use a stapler.
yes.
Cool.
Right up there.
Thank you.
You're welcome. All right, so please, parentheses, what do I do in the parentheses here? Anybody? Square the 5, right? Got to do the exponent before the subtraction, right? So it's 5. I'll do this each step, one at a time. Am I finished inside the parentheses? No, so subtract, what's that equal? -2. Okay, some of you don't keep the parenthesis and you leave it out, so then it looks like 5 minus 7 minus 2. Okay, but it's really not minus 2, what is it? It's times -2, right? So don't forget about that. That's where some of you made a mistake. You forgot that this means 7 times that, right? Now, what's next? I got the parentheses down. What's after parentheses? That exponent, right? So I'm going to do the 2 to the third. 2 times 2 times 2 is what? 2 times 2 times 2, 8. All right. Not a 6. That could have been a mistake you made. Okay, so now I've got my parentheses done, my exponents are done, multiplication, division. All right, I see both. So I just start reading the problem left to right, and multiplication shows up here. So that's 5. That's a negative, basically think of it as -7 times -2, which is +14. And then that looks like -16 divided by 8, so that's a -2. And then left to right, addition, 5 plus 14, and then subtraction. So you should get negative or positive 17. And if you didn't, that's okay. You don't really have to do it without a calculator, right? You can do it on the calculator. And just make sure you put it in just like it's written, all right? And your calculator knows or follows the order of operations. So I got 5 minus 7, parenthesis, 23 minus 5 squared, parenthesis, minus 16 divided by 2, use the caret there, to the third power, and it'll give you the 17. Okay? So just a little practice. And you won't get a problem looking like that. You'll get one that's got like X, Y, and Z in it. And then they'll tell you up in the directions what to plug in for X, Y, and Z. So then it ends up looking like that, okay, on your homework. Another type of problem on your homework that you'll have to do is they'll give you a couple intervals. And they're going to ask you to graph it. Okay? So we'll make our number line. I'll put 0 down here. All right, so what's that going to look like, this left interval, when I graph it? Michael?
Left interval,
Yeah, that one there.
it's going to be an open square. Fold to the left.
All right, an open circle at 0 and going to the left. You guys all okay with that? That makes sense? For that interval? We're not including the 0 because of the parentheses, right? So that's why it's a circle. All right? Liam, can you do this one, please?
Build in circle.
Yeah, and where else? Right. So it'd be all those numbers in there. So that's what they want you to do. You're gonna have a few problems like that. They're gonna give you some intervals. They want you to graph those intervals. They might also, instead of giving it to you in interval form, they might give it to you in set over notation instead, but you have something like that. Oh, you have a few problems where, they'll write an equation, and you'll look at the left side and the right side and see what's different. Did they change the order? You'd write commutative property of if it's multiplication or addition. Or did they change what was grouped? Then you'd write associative. Maybe they distributed, maybe they just substituted something. So you're just gonna write what property you think is being shown. And you're gonna simplify some expressions. Okay, so let's say you have something like that. They're gonna want you to simplify it. So what would I do first to simplify that? Yeah, can you do anything with the x plus 7? No, so you're gonna distribute, right? So you're gonna 5 times x, 5 times 7. Is it simplified all the way? We got, what do we call these? Like terms, right? So I put the like terms together to simplify it all the way. So it'd be 2x plus 35. So you have a few problems like that to finish up. You guys can handle that, can't you? Of course you can. So that's it for the day. Here's your assignment. Oh, this again, you're not going to be tested or quizzed on this, but just to remind you, the properties of equality. Reflexive property says that anything equals itself. It's like a reflection. Symmetric property says if A equals B, then I can switch the order and say B equals A. They're still equal. Transitive property says if A equals B and B equals C, well, then A has to be equal to C. And substitution is A equals B, then I can replace, then I can put B in place of A. Or let's say A equals 6, I can put a 6 wherever I see an A. Right? So you guys know that stuff. Again, you're not going to be tested, but I just wanted to remind you of those properties of equality. It's like when we solve equations. What you do to one side, you got to do to the other side, right? That's when you use those properties. There's your assignment. What's the 5 on the end mean? By 5. So you're going to do 55, then you're going to jump up to 60, and then go to 65, and then 70. So it looks like a lot of problems, but it really isn't. I think it's 11 problems. Maybe not even that. Well, maybe a little more. Yeah, it's coming down hard. We do need the rain though.
Yeah.
But it's nicer if it's a slow, steady one, not a daily.
I was at lunch and I went to Sheets and I came out and it was like monsooning outside. I was like, uh-oh.